Starting on page 6, we're going to be multiplying a binomial times a binomial, and then later we'll be multiplying a binomial times a trinomial. You know bi means 2. That means it has 2 terms in it. So notice here you have, the 5r minus 1 times the 2r plus 3. So basically this just follows the distributive property. That's a property we use all the time. So I wouldn't really say it's, completely new. It's just that we're just distributing twice versus once. All right, so we're going to take this 5r, the first term, and we're going to multiply it by the 2r. Okay. So I'm just going to distribute that. So that's going to give me 10r squared. And then I just multiply the 5r times the 3. That gives me 15r. So all I'm doing is just using the distributive property. And then I'm going to take, but there are 2 terms that I got to distribute versus 1. So now I'm going to start with the negative 1 and do the same thing. Negative 1 times the 2r is negative 2r. And negative 1 times 3 is negative 3, which is the same thing as minus 3. So once you're done distributing both terms to the other 2 terms, then you combine the like terms together. So these are my like terms because they both have r's in them. So 15r minus 2r will give me a total of how many? 13. Okay. And that's your final answer. Okay, so like I said, it's not completely a new topic because you already know how to use the distributive property. You're just distributing 2 terms instead of 1 on the outside. Okay, now in a few minutes, we're going to go over how do you take this trinomial and go back to the original problem, which was the 2 binomials together. So we're going to be working in reverse order in a few minutes and learn how to go from this trinomial back to the binomial. And we call that factoring. Okay, so that's going to be our second part of our lesson in a second. So let's take a look at number 20. We're still just using distributive property. You're just distributing twice. So I'm going to multiply 5r times 5r. That'll give me 25r squared. And then the 5r times the 2 will give me 10r. And then I take the second number, do the same thing, and multiply negative 5 times 5r, negative 25r. And negative 5 times 2 will give me negative 10. Combine your middle terms together because those are your like terms. So I'll have 25r squared. Okay, minus 15r minus 10. All right, any questions on that? And again, like I said, it's really not new. You're just distributing 2 terms versus 1. Now here in the second part, you'll see something that says first, outer, inner, last. That's an acronym we use for distributing twice. So when we distribute twice, which is really what we just did, we multiplied the first terms, then we multiplied the outer terms, then we multiplied the inner terms, and then we multiplied the last terms. So it's really just an acronym because it is like a common thing to multiply a binomial times a binomial. But as long as you know you're taking that first term and distributing it to both, and then taking the second, you really, if you want to remember first, outer, inner, last, you will hear that acronym a lot when you are distributing twice, okay? Just want you to know it's there. All right, so let's actually perform first, outer, inner, last, which is what we did in 19 and 20 as well. So 5m times 4m will give us 20m squared. And then 5m times the negative 2 will give us negative 10m. Now we take the negative 4 and distribute twice. negative 4 times 4m, negative 16m. And then what is negative 4 times a negative 2? Positive 8. And then again, we combine our middle terms together. So I'm going to have 20m squared minus 26m plus 8. So I'm going to have you do number 22, and then we'll check it in a minute. So minus, we have a negative 4 times a positive times a negative is a what? Negative. So we got 2 times 2p times 3p, 6p squared. 2p times negative 2 is negative 4. 4 times 3 is a positive 12. 4 times a negative 2 is a negative 8. Okay? All right. Okay, guys, so we're going to move along. There's another method called the box method. So instead of doing it horizontally, you could actually put it in a box. If you want to look that up, that's fine. I tend to just stick to, okay, my screen just stopped here. I tend to just stick to the FOIL method, okay, because it's just really using the distributive property. All right, so what happens if you're multiplying, let's go to 25, if you multiplying a binomial times a trinomial, all right? So it's still distributive property. You're going to take the x, multiply it by all three, then you're going to take the negative 1 and multiply it by all three and combine the like terms together. Now I'm going to do a vertical method, so I like to line my like terms up instead of going horizontally all the way across, and I'll show you what I mean by that if you follow along with me. So I'm going to take the x, and yes, I'm going to distribute that x to all three terms in that trinomial. So that's going to be 3x to the third, okay, minus 4x squared, okay, plus 5x. So that's just first taking the x term and multiplying it by all three. Now I'm going to take the negative 1, and I'm going to do the same thing. But notice this time I'm going to line them up underneath instead of continuing this way. I'm going to do it vertically. So I'm going to do 3x squared times negative 1 is negative 3x squared, because I want my like terms to already be underneath one another. Now, if you want to continue going this way, you definitely can continue going all the way across the page. That's an option. Then I'm going to multiply negative 1 times 4x. So that's going to give me a positive 4x. And by me doing this, my like terms are already underneath. And then a negative 1 times 5 will just be a negative 5. Okay? So now I'm ready to bring down my 3x to the third, negative 7x squared. I already got them lined up, so all I got to do is, add or subtract the coefficients, plus the 9x, minus the 5. Okay, and again, if you prefer to continue horizontally and combine them that way, you'll get the same answer. Okay, I just like because they're already lined up. All right, let's do 26. So we're going to take this 4r, multiply it by the 4r squared, 16r to the third. 4r times 4r is 16r squared. And 4r times 5 is 20r. All right, now I'm going to do the negative 3. Negative 3 times 4r squared is negative 12r squared. Negative 3 times 4r is negative 12r. And negative 3 times 5 is negative 15. Okay. Combine like terms together. So I'll have 16r to the third plus 4r squared. Okay, plus 8r minus 15. Any questions on that? So this is where we get into what we call factoring a trinomial. So what you're going to do now, remember I told you at the beginning of the lesson, you're going to determine what the factors are. Now keep in mind, factors are things you multiply together. So these are really factors, like 5r minus 1 is a factor. 2r plus 3 is a factor because we're multiplying them together, so they're called factors. Okay, so the numbers you multiply or the terms you multiply together are called factors. The answer you get is called the product. So think of this as the product. You have to now go back and say, what were the factors? Like, what was the binomial times the binomial before you got to this trinomial? So we're working backwards on this. Okay, so this one takes a little bit more effort, okay, to get back to what the factors are. So we call this factoring. Now I'm going to start with this section here. Now this section is the section that's going to be on part 2 of your homework. So like for you guys, as this is a B day, this is what you would do for homework on Wednesday. Tonight's homework, you're going to be doing this part, okay, of factoring. Now what's the difference with these types of problems? And I want you to tell me, look at the x squared terms in this section here. Okay, all the x squared terms, what's the coefficient in front? What's that invisible number? 1. Okay, so see, it says the leading coefficient is 1. Here, look at the squared terms, and they're greater than 1. Do you agree? You got 3 here, 4 here, 4 here, 6, 6, and 5. So when you're factoring and that x squared term or the squared term is greater than 1, there's a particular method that we're going to be using. This part, I'm going to show you a quicker way to factor when the leading coefficient is 1. These are very easy to do. Okay, so I'm going to start off with the ones that, require a little bit more work, because if you can do the ones that require a little bit more work, the top part will seem very easy. All right, so we're going to go over something that I need to go over with you first. So you need to take some notes. I would prefer that you put this in your spirals. Okay, and this is called the X method for factoring. Okay, this is the X method for factoring. And you definitely want to put a title at the top that says factoring. Yes, well, I had a student one time to just call it the X Factor. Remember, I think that was like a TV show or something. Yeah. So she came up with a nice name and said, hey, let's just call it the X Factor. I said, that's a nice thing to do. All right, so now when you're factoring this way, and keep in mind, and I'm going to take this problem here. Let's just take one of the problems. 5p squared. And let's write this by our x, because we're going to be using this as an example. Okay. So we're going to use 35, which says 5p squared minus 26p minus 24. Okay, so I'm going to keep this over here off to the side. This is question number 35 on the previous page. Now, what you have to know, you got to know some background information first. Okay, first, this is called a quadratic expression. Okay, it's called a quadratic expression because it has a squared term in it. All quadratic expressions follow this pattern. The first term is called your a term. So I'm going to say ax squared. So the squared term is always considered a. It's called a, like a is 5. This term here is your b term. Okay, so that's the x term. So if I ask you what's b, you would say negative 26. So what do you think this term is called? We're going in order. C. C is always your constant. Okay, that means it doesn't have a variable. So C is your constant. All right. C is your constant. And that is how we label a quadratic function. So when I put some letters up here, you'll know what numbers I'm referencing. So at the top, we're going to take the a term, and we can make it capital or not. It doesn't matter. So you're going to multiply the a and c term, and you're going to put that there. Okay, we'll do it in a minute. The b term will go here. So that's why I said you got to know how they are numbered, or lettered, that is, or named. And then on the side, these are going to be your factors. So I'm just going to use F for factor. So factor 1 and factor 2, because now factors are numbers you multiply together to get a product. Remember, we just said that. So those would be called your factors. And then you're going to take the factors and divide it by the A term. Okay? You're going to take the factors and you're going to divide it by the A term. All right, so that's how we're going to actually factor this whole 5p squared minus 26p plus 24. All right, so let's try it. So this at the top says take the A term, which is 5, multiply it by the C term, which is negative 24. So I want someone to tell me what 5 times negative 24 gives you. Yes. All right, so we're going to put that number at the top, negative 120. So how do we get that again? We multiply the A and the C term together. Okay, so you might even want to put up there 5 times negative 24. Okay, that's how you got that number right there. Okay. All right, the B term is here. Okay, you don't have to do anything with the B term except for place it where it goes at the bottom. So that's negative 26. Okay. All right, so this is the key. This is where you got to start thinking. So 1 times what will multiply and give you the top number of negative 120, but when you add them, the two factors together will give you negative 26. And you said, wow, well, there are a lot of factors that will give you negative 120, but which ones add up to negative 26? So this is where your calculator will help. Okay, so go to page 4. Okay, I'm going to show you something on page 4. So guys, you don't even have to try to figure all of this out, because I'm going to show you how you can get the factors right on the calculator. Okay, so on page 4, we have this nice example of how you can get the factors. Like this example would be factors of 72. So I want you to pay attention for a second. So let's just say we had the number 72. Ours is negative 120, but let's just say we had 72. So once you type in 72 divided by x, and then I'll show you how to get this x plus y1, then look, see what happens over here in the table? They give you all the factors of 72. 1 times 72, 2 times 36, 3 times 24. They will give you all the factors of 72. You don't even have to figure it out on your own. Okay? This column right here would be like your B column. So you don't even have to figure out adding these two together. They've already done it for you. 1 plus 72 is 73. They've already added the factors together. So this part will be very easy if you know how to use your calculator. Okay, so let's put this into our calculator. Let me pull up mine. Okay, we're going to hit the y equals key, and then we're going to type in negative 120 divided by x. Okay. Oh, I did times. Hold on. Delete that. All right. And then go down to your second row, and it tells you what to press. So you're going to press what first? X. Plus sign. Okay, then hit your alpha key. There's your alpha. And then hit trace. Trace is right beside graph. When you hit trace, this little window will pop up. Okay, and just hit enter because you want it to be on Y1. Okay, everyone there? Okay, and if not, just go back to your directions on page 4. And now we want to go to the table, so hit second, graph. So I'm looking in this column right here for the B term. So the B term on my calculator is in red. So that's the Y2 column. I want the B to be what? Negative what? 26. There it is right there. So what are the factors then? The factors are 4 and negative 30. How many people see that? Great. So you didn't even have to figure it out on your own. There it is right there on your calculator. So look for your B term on the calculator, and then there you have your factors. All right, so let's go back to our worksheet that we were doing. Okay, yours is in your spiral. So now we're going to see where I have factor 1 and factor 2. It doesn't matter where you place them. I can put the 4 here, or I can put the 4 here, and vice so it doesn't matter. So I don't want you to think that the X factor, the one that's in the X column has to go first. It doesn't matter. Okay, so this is going to be 4, and this is going to be negative 30. So those were my factors off the calculator. And yes, it multiplies to get negative 120, and it adds together to get my negative 26. Okay, I'm not done because I have to divide it by what? The A term. What is the A term? Look over here. 5. So I'm going to divide it by 5. Okay. And then you reduce if you can't. I cannot reduce 4/5, but can I reduce negative 30 over 5? Okay, yes, I can reduce that to negative 6 over 1. You have to have two numbers. So you can't just reduce it to negative 6. You got to say negative 6 over 1. Okay, you got to have two numbers at all times. So now we're ready to write our answer. I'm going to show you how you get the answer from these fractions. So what you're going to do, we call it bottoms up. You start from the bottom to the top. So the bottom number is considered your X number. I'm just going to put a little X down here. The bottom term is always your X term. So when I start from the bottom and go to the top, I'm going to write 5x plus 4. That's my first binomial. Start at the bottom, 5x plus 4. Now I'm going to do the same thing to this reduced fraction. Start at the bottom. I'm not going to write 1x. I'm just going to write x minus 6. Doesn't matter again which one you write first. If I had written x minus 6 times 5x plus 4, it's the exact same answer. Because it doesn't matter the order that you multiply. That's the commutative property. There's our answer. 5x plus 4 times x minus 6. So now we have just considered this in factored form. Okay, and that's where you would actually write your answer for number 35. Right? So now, that took a very long time to explain, but trust me guys, once you get this method, it does not take that long. Okay? It takes a long time to explain it for the first time, but once you get the hang of it, it really does not take a very long time. Let's look at 37. Okay, so I'm going to make an X right here by 37, because now I know where the numbers should go. So at the top of my X, I need to multiply 6 times 25. Okay, so can somebody multiply 6 times 25 for me? All right, 150. That's going to go at the top of my X. Who remember what goes at the bottom? B. B is what in this case? 25. Very good. So see how fast it's going already. So now all I need to do is go to my calculator and put in 1. You don't need to change the Y2 column. You already have that set like you want it. That X plus Y1 will stay. You only need to change Y1 to 150. So we're going to do 150 divided by X. Okay, and then I'm going to go to the table and I'm going to look for my B term. What was my B term again? My B term was 25. Okay, so I might have to cursor down a little. All right, so there's 25. 25 is right here. So what are my factors? 10 and what? 10 and 15. Very good. So I'm going to go back to my worksheet, and I'm going to put in my factors 10 and 15. Now, I'm not done because I have to divide it by the A term. What is the A term over here? 6. Very good. Okay, let's reduce this fraction. So I can divide both by 2. So this is going to be what? 5 over what? 3. Okay. And then on this side, I can divide both by 3. So what is this going to be? 5 over 2. Very good. You have your fractions. Now you're ready to start from the bottom up. Remember, the bottom number is x. So my factors are 3x plus 5 and 2x plus 5. Okay? And like I said, once you do a few of these, it actually gets even faster. Okay? All right, we're going to do one more. And like I said, guys, this is really your next lesson. Okay, so like I said, you'll be able to do the next homework assignment as well. So if someone can multiply 6 times 30, we're going to make our x. 6 times 30 is what? 180. So my bottom number is 41. Okay, B for bottom. We're going to go to our calculators and put in 180 divided by x. We don't need to change the second row. Okay, we're going to go to the table, and we are looking for, what's our bottom number again? 41. Okay, so I might have to cursor. Did you guys find it? What are the factors? 5 and 36 right there. Okay, here's 41, so you're going to be using 5 and 36. Okay, so we're going to go back, put in 5 and 36. Doesn't matter which side you put it on. Okay, 5 and 36, we're going to divide it by the A term. What's the A term? 6. Very good. So I can't reduce 5, 6 anymore. That's already in simplest form. How can I reduce 36 over 6? 6 over 1. Remember, you always got to have two numbers. Okay? Who can tell me how to write these as my binomials? All right? Go ahead, Jordan. Very good. Very good. Excellent. That's it. Okay? And like I said, the more you do, the faster it'll become. It just takes a very long time to explain the whole setup at first, but your calculators are really helping you out a lot because you don't even have to figure out the factors. Okay. All right, now I'm going to show you the quick way. This is tonight's homework for most of you because the A term is just 1. So you don't necessarily have to do that whole 1 times 8 and 1 times 14. I'm going to show you a quick, easy way to do these. Now, can you? Yes. But to me, you don't need to. And I'm going to tell you why. Okay? So this is all you got to do. You take a look at these two terms right here when that first number is 1. And basically what you're saying to yourself is, what times what will give me the C term? In this case, it's 8. So what are the factors of 8 that equal to 6? That's what you got to say to yourself. So that's why those two terms are important. So what times what gives you 8? But when you add those what and what, it equals to 6. Isn't it 4 and 2? So all you say is x plus 4. Oops, me. And x plus 2. Doesn't matter which one you write first. Now I use x's all the time. So I don't use n's and r's and a's and b's and p's and all of that. I stick to just using x's. If you want to change the variables to what they are in the problem, you can definitely do that. Okay, but I just stay standard and just say x for everything. Okay. All right, so multiplication facts. What times what gives you 7? Sorry, 14. What times what will give you 14? And when you add those two factors together, they equal to 9. 7 and 2. So that's why I say you don't really need to do the X factor thing for these type when the coefficient is 1 for the A term. Switch gears a little bit because now we got to say what times what equals negative 27. But when I add it together, will give me a positive 6. Now I know 9 and 3 is 27, but which one needs to be negative so when I do add them together, it will still equal to a positive 6. Okay, Diddy? All right, right. So the 3 would actually have to be minus. So x minus 3, x plus 9. Okay, because when I combine them together, they must equal to a positive 6. All right, let's do 32. So what times what gives you negative 20, but will equal to a positive 8? Yes, Jordan. All right, right, 2 and 10. So which one needs to be positive? The 10? I mean, is that right? Yes. Okay, so x plus 10. And what was the other factor? Minus 2. Okay, so does everybody see why you wouldn't necessarily have to do the X method for when the coefficient is 1? You really don't need to do that. What times what gives you negative 56 but equals to negative 15? How about this? X minus 7 and x minus 8. Is it a negative 8 and a negative 7 a positive 56 when you multiply, but a negative 15 when you add them together? All right. What times what gives you 18 that equals to a negative 9? A negative 6 and a negative 3? Will that work? Yes? Yes, it will. Okay. Now, so, and again, if you like the X method and you still want to do it when the coefficient is 1, that's totally up to you. It works. But it's not necessary. Okay? The X method is more necessary or extremely necessary when that coefficient is greater than 1.